Hello students, welcome to time classes. I hope you are fine and taking good care of yourself. Today's session is on indices and surds. In this topic, we are going to learn first of all what do we mean by indices. Then we'll look at the rules of indices and try and solve different varieties of problems where we will see the application of those rules. Then we will learn what are surds. We'll learn the process of rationalizing a surd. We'll learn the process of finding square root of a surd, and we'll also learn how to compare two surds. I hope you are set for the session and you have the required handout, which is QAHO 1002125. Okay, let's begin with the session. So let us look at what are indices. So suppose we have a quantity A added 3 times. So we have A plus A plus A. So we'll write that as 3A. Okay. So A added 3 times becomes 3 times of A, isn't it? Now suppose we multiply A 3 times. So A into A into A, that is A to the power 3. Now the 3 which you see in the power, it is known as power and it is also known as index. The plural of index is indices. Okay, and we also know it as exponent. I am sure you are familiar with the word power and exponent, and power and exponent, the other name for them is index and the plural is indices. So in this A to the power 3, A is the base and 3 is the power, or 3 is the index, or 3 is the exponent. Okay, so when we write A into A into A, it means A raised to the power 3. So similarly, can I say A into A into A and so on n times? So if I multiply A n times, can I say it will be A to the power of n? So here A will be the base and n will be the index or power. Now remember, this n, which is the exponent or the index, it is not necessarily a natural number or a positive integer. This n can be any real number. It means it can be an integer, it can also be a rational number, it can also be irrational number. So in short, it can be any real number. Fine. Alright, now next we'll look at the rules of indices. We will understand them with one example for each of the rules, and then we will move on to solve a few problems based on the rules. Okay, fine. So let's look at the first rule. So rule number 1 is A to the power m into A to the power n is equal to A to the power m plus n. So now you have to notice that the base in these two are same, both are A and they are multiplied. So if that happens, then the powers will get added. So the base A remains base A and the powers m and n, they were added. So this rule is known as product rule. So what do we get finally? As an example, if you see 5 to the power 2 multiplied with 5 to the power 7 will become 5 to the power 2 plus 7, which is 9. Okay. Rule number 2. Rule number 2 is known as quotient rule, because we are dividing one quantity by the other quantity, or you can say division rule. So when we say A to the power m divided by A to the power n, in that case again you notice the base is same. Here also we have A and here also we have A. In that case we can write it as A to the power m minus n. Okay. So in this case power will get subtracted. In the product rule, what happened? The power was added. In the quotient rule, what will happen? The product will get the power will get subtracted. Okay. So as an example, let's see 7 to the power 5 divided by 7 to the power 3. So that will become 7 to the power 5 minus 3, which is 2. So 7 to the power 2, that is 49. Fine. Okay. Rule number 3. This is known as exponent rule. So we have a to the power m whole to the power n. A to the power m, the whole thing to the power n. So in that case, the powers will be multiplied. So we'll have m into n. Okay, we'll have m into n. So a to the power m whole to the power n will mean a to the power of m into n. So as an example, if you see 4 to the power 2 whole thing to the power 3, that will become 4 to the power 2 into 3, and that is how you got 6. So 4 to the power 2 into 3 is 6. Now you have to keep in mind the difference between these two. So when we write a to the power m whole to the power n, and when we write a to the power m to the power n, these two are not the same. Okay, these two are not the same. So we have to understand the difference. So when, for example, if you take this example here, so I have taken 2 to the power 3 whole to the power 2. So 2 to the power 3 whole to the power 2, and I have taken another example, 2 to the power 3 to the power 2. So in this case, first of all 2 to the power 3 will be calculated, which is 8. Okay, and then 8 to the power 2, this power 2 is here, 8 to the power 2 is 64. Okay, this could also have been written 2 to the power 3 whole to the power 2, means 3 and 2 will get multiplied. So we are applying this rule. Okay, so that becomes 2 to the power 6, which is 64 only, right? But in this case, we have to be very careful. In this case, first thing we will do is we will calculate 3 ka square. So what is 3 ka square? 3 ka square is 9, and then we will calculate 2 to the power 9, which is 512. Okay, so this was 64, but here we got 512. Obviously they are not the same. Fine, I hope you have understood the difference. So in general, a to the power m whole to the power n will not be equal to a to the power m to the power n. Why I am saying in general is because there can be exception. So for example, if I take a as, let us say, take a as 1. So if you take the base as 1, in that case these two will be equal, because anyways 1 to the power any number will always give you 1, right? So we can have some exception, but this is in general. Okay, so a to the power m whole to the power n won't be equal to a to the power m to the power n in general. I hope the difference is clear to you. Alright, let us look at fourth rule. So what to do when we have negative power? So here you see we have a to the power minus m. Okay, we have a to the power minus m. So that can be written as 1 by a to the power plus m. Okay, that can be written as 1 by a to the power plus m. Fine. Now you can write this as, what happens is this, you just take the reciprocal of the base. So in place of a, you take reciprocal of a, which is 1 by a. If you do that, the power will become positive. So minus m will become plus m. So 1 by a whole to the power m is nothing but 1 by m to the power a by m, and 1 to the power m is nothing but 1, right? 1 raised to the power any number will give you 1 only. So you can write it like this. So that is what happened. A to the power minus m can be written as 1 by a whole to the power plus m, and that can be further written as 1 to the power m divided by a to the power m. 1 to the power m will remain 1, so you can write it as 1 by a to the power m. So we can write this as 1 by a to the power plus m. So as an example, if you see 2 to the power minus 3, it can be written as 1 divided by 2 to the power plus 3, and 2 to the power plus 3 we know is 8. So 1 by 8, which is 0.125. Now what if we have a by b? We have a fraction a by b whole to the power m. A by b whole to the power m. whole to the power minus m, sorry, a by b whole to the power minus m, that can be written as b by a whole to the power of m. So since here the power was negative, it was minus m, you take the reciprocal of the base. Here the base is a by b, so reciprocal will become b by a, and the power will become, in place of minus m, it will become plus m. So that is how you convert a negative power to positive power, by taking the reciprocal of the base. Fine. Fifth rule, we have mth root of a. This is known as mth root of a. So this sign you see is the sign of root, or we call it as a radical sign. Okay, the sign that you see is the sign of radical, or we can say the sign of root. So mth root of a can be written as e to the power 1 by m. So for example, square root of a, which is the second root of a, can be written as e to the power 1 by 2. Third root of a, which is same as saying cube root of a, can be written as a to the power 1 by 3. Fourth root of a can be written as a to the power 1 by 4, and so on. So mth root of a can be written as a to the power 1 by m. So as an example, you see cube root of 64 can be written as 64 to the power 1 by 3, and 64 to the power 1 by 3, we know cube root of 64 is 4, right? Because 4 to the power 3 gives me 64, isn't it? So 64 ka cube root is 4. Fine. Now in general, what we have is, see, a to the power n and mth root of that. So mth root of a to the power n will convert into a to the power n by m. Okay, so this can be written as a to the power n by m. So this m will come in the denominator and this n will be in the numerator. Okay, fine. Alright. Rule number 6. A into b whole to the power m can be written as a to the power m into b to the power m. So basically in side bracket you have a into b multiplied together and you have a common power m. So you can separate and write it as a to the power m into b to the power m. So for example, 2 into 3 whole to the power 4 can be written as 2 to the power 4 into 3 to the power 4. Okay. Rule number 7. A by b whole to the power n. So these two rules are similar. For product and quotient, if the power is common, you can separate and write it as a to the power n divided by b to the power n. Okay. So a by b whole to the power n can be written as a to the power n divided by b to the power n. Fine. So for example, 3 by 4 whole to the power 2 can be written as 3 to the power 2 divided by 4 to the power 2, which is equal to 9 by 16. 3 square is 9, 4 square is 16. So all these rules that we are looking here can be used both ways. Okay, so we can write a by b whole to the power n as a to the power n by b to the power n, and you can also write a to the power n divided by b to the power n as a by b whole to the power n. Okay, similarly this first formula, your first rule, a to the power m plus n, here a to the power m plus n can be written as a to the power m multiplied with a to the power n. So you can use all these rules the other way around also. Fine. Alright, let's look at rule number 8. A to the power 0 is 1. So any number raised to the power 0 is 1 provided that number or the base is not equal to 0. So we can say any non-zero number raised to 0 power will always give you the value as 1. 3 to the power 0, example, 3 to the power 0 will be 1. Okay. Similarly, a to the power 1 will be equal to a. That's very easy. Any number raised to power 1 is equal to the same number, right? So for example, 4 to the power 1 is nothing but 4. Fine. Okay. So these are the rules we have. In addition to this, we also have these two rules. So if a to the power x is equal to a to the power y, then x is equal to y. So this is an equation where the base on both sides are equal. Here also we have a, here also we have a. So in an equation, if the bases on both sides are equal, then the powers also must be equal. Okay, so this implies that x will be equal to y. Now this will be true in general. There can be some exceptions. So for example, a can't be 0, a can't be 1, a can't be -1. Because if you have, suppose a is equal to 1, so 1 to the power any number will give you always 1. Okay, in that case the power need not be equal. For example, 1 to the power 5, 1 to the power 5 is equal to 1 to the power 6. So the bases are same, but 5 is not equal to 6. So powers are not same. Okay, so this is an exception. But in general this will be true. Similarly, if a to the power x is equal to b to the power x, here the powers are same, right? In this equation, on both sides the powers are same, so that will imply that the bases also must be same. Okay, so in a nutshell we can say, in an equation, if on both sides the bases are same, then the powers must be equal, and if the powers are same, then the bases must be equal. But here also we have some exception. Okay, x should not be even in this case. What is the problem? Let's understand with an example. So suppose we have 3 to the power 4 and -3 to the power 4. So 3 to the power 4 will give you 81. Okay, and -3 whole to the power 4, that will also give you 81. So LHS is equal to RHS, right? So these two are equal. But is 3 equal to -3? No, that is not correct. 3 is not equal to -3. So you see, when the power is even, so power is even, which is 4, then we can't have necessarily a is equal to b. Fine. So this also, the rule a to the power x is equal to b to the power x implies a equal to b is not true always. There can be some exceptions. Okay, but we can say in general, if the bases are same, then the powers are equal, and if the powers are same, then the bases are equal. Fine. I hope it is clear till now. Now there are three types of questions that you will see. So we have questions based on simplification of some expression, which will involve some power of some number or some power of some variables. Then we'll have the type of questions where we have to solve to get the value of the unknown. So we have to solve, there will be a kind of equation which we have to solve and get the value of the variable. And this equation will contain expressions which will have some power. Okay. And the third type will be where we have to compare a few numbers. When we compare numbers, remember these will be numbers which will have some powers again. Okay. Alright, so let us look at some examples in your sheet. So let's start with simplification questions. Question number 1, part 1 of your sheet. Okay. So here the question says simplify 3125 whole to the power 5 into 625 whole to the power -4 into 125 whole to the power 125 divided by 5 to the power 6. This sign is division sign. Okay, this is divided by. Fine. Let's see how to solve this. So 3125 is nothing but 5 to the power 5. Okay, 3125 is nothing but 5 to the power 5, and there is another power 5, so 5 to the power 5 whole to the power 5. Okay, then we have 625. 625 is what? 625 is 5 to the power 4, right? 625 is 5 to the power 4 and whole to the power -4. Then we have 5 to the power 3, which is 125, and whole to the power 125, and divide by 5 to the power 6. So 5 to the power 6 comes in the denominator. Okay. What do we get here? 5 to the power 5 whole to the power 5. So we'll get 5 to the power 25. This will become 5 into 5, 25. This will become 4 into minus 4, which is minus 16. And this will become 3 into 125, which is 375. Now we will have the same base 5 in all these three cases in the numerator, and we have the product, right? So we have the same base and we have the product, so powers will be added. So 25 plus minus 16 plus 375, and we are dividing it by 5 to the power 6. So the power 6 will be subtracted because here also the base is same and 5 to the power 6 is in the denominator. So in the end we will have the base is same everywhere. So we'll have 5, 25 plus of minus 16 plus of 375, and this 5 to the power 6 was in the denominator. So its power will be subtracted. So minus 6. So if you solve the power here, then we'll get 378. So finally we'll get 5 to the power 378. Okay. So after simplification, the value of this entire thing is equal to 5 to the power 378. I hope it is clear. Alright, let's look at the second part. So here we have 729 by 343 whole to the power 1 by 6 multiplied with 625 by 49 whole to the power minus 1 by 4 multiplied with 125 by 729 whole to the power 1 by 3. Okay. Okay. Let us see how to solve. So 729 is nothing but 9 cube and 343 is nothing but 7 cube. So can I write 9 by 7 whole cube? And there is another power which is already there, 1 by 6. So it is 9 by 7 whole cube whole to the power 1 by 6. So the power 3 and power 1 by 6 will get multiplied together. So we'll get 3 by 6. Okay. Then 625 can be written as 5 to the power 4. 49 can be written as 7 square. And we can separate the power and write it as 5 to the power 4 whole to the power minus 1 by 4 and 7 square whole to the power minus 1 by 4 again. Here 125 can be written as 5 cube. 729 can be written as 9 cube. And whole to the power 1 by 3. So in this case, we'll have 5 to the power 3 whole to the power 1 by 3. So 3 and 1 by 3 will get multiplied together. So we'll get 1. Here also 3 and 1 by 3 will get multiplied together. Again we'll get 1. So in the next step, we'll have 3 by 6 is what? 3 by 6 will be 1 by 2. Okay. So we can write 9 raised to the power 1 by 2 divided by 7 raised to the power 1 by 2. Okay. 9 raised to the power 1 by 2 is same as square root of 9. The square root of 9 is what? 3. Square root of 9 is 3. So we'll get 3 here. Okay. In the denominator, we will have 7 to the power 1 by 2 because 3 by 6 is 1 by 2. So we'll get 7 to the power 1 by 2. Here we'll have 5 whole to the power 5 to the power 4 whole to the power minus 1 by 4. 4 into minus 1 by 4 will give you minus 1. And here 2 into 1 by 4 with a negative sign will give you minus 1 by 2. So 5 to the power minus 1 divided by 7 to the power minus 1 by 2. Multiplied with 5 by 9. As I already discussed in the previous step, here we'll have 5 to the power 3 into 1 by 3. So we'll get 5 to the power 1. And here we'll have 9 to the power 3 into 1 by 3 again, which will again be 9 to the power 1. So we'll get 5 to the power 1 by 9 to the power 1, which is nothing but 5 by 9. Okay. So finally we'll have 1 by 3. So what will happen here is, this can be written as 3 divided by 7 to the power 1 by 2 into, here we have 5 to the power minus 1. So 5 will go in the denominator and we can write 5 to the power plus 1. And here we have 7 to the power minus 1 by 2. So if we take the reciprocal, 7 will go up in the numerator and the power will become positive. And into 5 by 9 was already there. 7 to the power 1 by 2, 7 to the power 1 by 2, this will cancel out. 5 and 5 will cancel out. 3, so you can cancel 9. So finally you will get 1 by 3. Okay. So this is the answer, 1 by 3. Fine. I hope this is clear. Alright. Let's look at next example. Question number 2, first part. So a plus b plus c is equal to 0. X is not equal to 0. So what is the value of x to the power a to the power 4 divided by a square into bc? This entire thing is in powers. Okay. This entire thing is in the power of x. Multiplied with x to the power b to the power 4 divided by a into b square into c. Multiplied with x to the power c to the power 4 divided by a b c square. So this expression is in powers, this expression is in power. The base is same here in all the three cases, it is x. Okay. So it is given that a plus b plus c equal to 0. It is given in the question. Now if a plus b plus c equal to 0, then we'll have a cube plus b cube plus c cube will be equal to thrice of abc. How did we get this? This is based on an identity. So this is that identity. So this identity is a cube plus b cube plus c cube minus 3abc is always equal to a plus b plus c multiplied with a square plus b square plus c square minus ab minus bc minus ca. So if you look at this identity carefully, if a plus b plus c is equal to 0, if this is equal to 0, so can I say this entire right hand side will become 0, isn't it? Because this entire thing is 0 and 0 multiplied with anything here will give you 0. So if a plus b plus c is equal to 0, then the entire right hand side will become 0. So we will have a cube plus b cube plus c cube minus 3abc is equal to 0. So we can say a cube plus b cube plus c cube will be equal to plus 3abc, because this minus 3abc will go on the right hand side, it will become plus 3abc. So that is what we said. If a plus b plus c is equal to 0, then in that case a cube plus b cube plus c cube is equal to thrice abc. Okay. Now let us simplify this. So this is the same expression which was written. Now since the bases are same, can we write base will be x and the powers will be added? Okay. So we'll have a square by bc. How did we get a square by bc? Because this a square and a to the power 4. So we will get a to the power 4 minus 2, which is a to the power 2. Okay. Because we have the quotient rule, a to the power 4 divided by a to the power 2. That will become a to the power 4 minus 2, which is a to the power 2. So we'll get a square by bc. Similarly, here we'll get b square by ac, and here we'll get c square by ab. And since we have the product here, so powers will be added because the base is same everywhere, which is x. So we have to add the powers, a square by bc plus b square by ca plus c square by ab. So if you do that, taking LCM of bc, ca and ab, you will get abc. Now this is the LCM ABC. ABC divided by BC will give you A, and that A will be multiplied with A square. So A into A square is A cube. Similarly, in the second term you will get B cube here. In the third term you will get C cube here. Okay. So now what is A cube plus B cube plus C cube? From here it is thrice of ABC, right? So now a cube plus b cube plus c cube is 3abc divided by abc. So this abc and abc will cancel out. So we'll be left with x to the power 3. Fine. So final simplification will give you x to the power 3. I hope this is clear. So let's look at the next example. This is question number 10, first part in your sheet. So we have first term as 1 divided by 1 plus a to the power minus 2 plus a to the power minus 3. second term we have 1 divided by 1 plus a to the power minus 1 plus a to the power 2, and in the third term we have 1 divided by 1 plus a cube. So what we'll do first is convert all the negative powers to positive powers. So a to the power minus 2 can be written as 1 by a square, a to the power minus 3 can be written as 1 by a cube, a to the power minus 1 can be written as 1 by a, and leave the other terms as they are. Fine. So in the first step what we have done is just converted the negative powers into positive powers. Now in the next step what we'll do is, in the denominators of all the three terms we will take the LCM. So what is the LCM of a square and a cube? It will be a cube. Fine. So that a cube will come in the numerator, and here you will be left with, since so we are using the LCM for adding these three terms, alright. So the LCM will be a cube. A cube into 1 gives you a cube. Here we already have a square, so we'll have a here, and here we already had a cube, so here we'll have 1. So this denominator, the LCM a cube, will go up and get multiplied with this one. So we'll get a cube divided by a cube plus a plus 1. Here we'll have 1 plus 1 by a plus a square, means the LCM will be a. So a into 1 is a, 1 is 1, and a square into a will give you a cube, and this will a will go in the numerator. Okay, and here we already have 1 divided by 1 plus a cube. Fine. So now look closely in the denominator, here, here, and here. So all these denominators are the same. We have a cube plus a plus 1 in all the three terms. So when we take the LCM of these three sum, so we take the LCM of the denominators here. So since the denominator is same everywhere, so LCM will be 1 plus a cube, and the numerators a cube plus 1 will be added. So ultimately we are going to get a cube plus a plus 1, and the denominator also is a cube plus a plus 1. So this will cancel out, the numerator and denominator will cancel out, and we'll get final answer as 1. Okay. This is a very simple example. You just have to convert the negative powers to positive ones, then take the LCM, simplify the terms, ultimately everything will cancel out, we'll get 1 as the answer. Okay. There is a little trick also that you can use here. You can take some random numerical value for a, put in the expression, and get your answer. And the easiest value to take will be, take a is equal to 1. So if you take a is equal to 1 and put the value of a equal to 1 everywhere in this expression, and you solve, and you will get the value of the entire expression as 1. Because if you take a as 1, then it becomes very easy. A to the power minus 2 will be, a to the power minus 2 will be 1 to the power minus 2, and 1 raised to any power will give you 1 anyways. So here you will get 1, again 1 to the power minus 3 is 1. So this will be 1 divided by 1 plus 1 plus 1. So this is 1 divided by 3. So this first term will be 1 divided by 3. Similarly the second term also will become 1 divided by 3, because in the denominator we'll have 1 plus 1 to the power minus 1 is 1, 1 square is 1, and here also we'll have 1 by 3. So 1 by 3 plus 1 by 3 plus 1 by 3 is nothing but 1. Okay. So that way it will become very easy. Just plug the value a equal to 1 in this entire expression and simplify and solve. I hope it is clear. Okay. Let's look at 10th second part. In this case there is a condition given that a into b into c is equal to 1. Then what is the value of 1 by 1 plus ab plus 1 by 1 plus b plus bc plus 1 by 1 plus c plus ca. Okay. Now let's see how to do this. So ABC is given as 1, that means a into b into c is equal to 1. So first term, this one, leave it like that only. So 1 divided by 1 plus a plus ab. Now here what you do is 1 divided by 1 plus b. Now in this place bc, since a into b into c is 1, can I say bc will be equal to 1 divided by a, right? A into b into c is 1, so b into c is equal to 1 divided by a. So in place of bc you can write 1 by a. Fine. In the third term we have 1 plus c plus ca. Now instead of c, can we write 1 by ab? A into b into c is 1, so c will be equal to 1 by ab. And instead of ca, can we write 1 divided by b? Because a into b into c is 1, so c into a will be equal to 1 divided by b. That is what we have written in the third term. Okay. Now simplifying further, the first term you can leave it as it is. In the second term you take the LCM, so 1 plus b plus 1 by a. Taking the LCM, it will become a plus ab plus 1, and the denominator a will go up in the numerator, it will come here. Okay. In the last term you take ab and b, the LCM of ab and b will be ab, so take the LCM as ab and simplify. The LCM ab will go up and you will be left with ab into 1 is ab plus 1 plus a. Now as you see, the denominator of all these three expressions become equal, right? The denominators are equal everywhere. So you can take the LCM as the denominator and then you can add the numerator. So ultimately what you will get is, again, numerator and denominator will be same, they will cancel out and you will get the answer again as 1. Okay. So the answer again once again is 1. So if you have noticed carefully, in this and in this, what we are trying to do is we are trying to make the denominators equal. So that is our primary target for solving these type of problems. What we try to do is we'll try to make the denominators as equal so that we can simply add the numerators. Fine. So that is what we are trying to do in both the examples. But in this example also, the second example also, we can use a trick here. Now in this case it was given that a into b into c as 1. There was no such restriction in the previous example. So we simply took a as equal to 1. Here we have three things, a, b, c. Their product is equal to 1. But here also we can take some numerical values and solve. So what we do is take a as 1, b as also 1 and c as also 1. So if I take all the values of a, b, c as 1, a into b into c is still equal to 1. So I am not violating this primary condition given in the question. So now what will happen if you take a equal to 1, b equal to 1 and c equal to 1. So these values you put in this expression. Okay. So once you put that into the expression, you will again get 1 by 3 plus 1 by 3 plus 1 by 3, which will again give you the value as 1. Okay. So here also you can play this smart trick and get your answer easily. Okay, fine. Alright, now let us look at this question. This is question number 11 on your sheet. It says 7 to the power x is equal to 2 to the power y is equal to 14 to the power z. Express z in terms of x and y. Okay. How to do this? Let's see. So let us say all of these values, they are all equal to k. Fine. So we'll try and write 7, 2 and 14, all those values in terms of k, x, y and z respectively. So from here, since 7 to the power x is equal to k, can I say 7 will be equal to k to the power 1 by x? So this power x, if it goes on the right hand side, it will become k to the power 1 by x. Okay. If we have 7 to the power x is equal to k, then if you take this power on the right hand side, it will become k to the power 1 by x. Okay. So similarly 2 can be written as k to the power 1 by b, sorry, k to the power 1 by y, and 14 can be written as k to the power 1 by z. Fine. So we have got the value of 7 in terms of k and x, we have got the value of 2 in terms of k and y, and we have got the value of 14 in terms of k and z. Now what we know about 7, 2 and 14 is 14 is equal to 7 into 2, isn't it? 14 is nothing but 7 into 2. Fine. So now put the values of 14, 7 and 2 from this expression. So what do we get? 14 can be written as k to the power 1 by z, 7 can be written as k to the power 1 by x, 2 can be written as k to the power 1 by y. Alright. So now can we write this as k to the power 1 by z will be equal to k to the power 1 by x plus 1 by y, isn't it? Because the bases are same and we have multiplied them together, so powers will get added. So we'll add 1 by x plus 1 by y. Now you look at both sides of this equation. Base is same, base is k on both sides. So if the bases are same, then the powers also must be equal. So therefore 1 by z will be equal to 1 by x plus 1 by y. So 1 by z is equal to 1 by x plus 1 by y, and then you can simplify this further to get the value of z. You will get x into y divided by x plus y. So take the LCM on the right hand side. Here you take the LCM. So we'll get x into y. In the numerator you will get x plus y. So then you take the reciprocal. So 1 by z ka reciprocal is z, and on the right hand side you will get xy divided by x plus y. Okay. I hope this problem is clear. Alright. Now let us look at some examples of question where we have to find the value of variable or variables. We can have more than one variable also. So let us look at this question. This is question number 3 on your sheet. It says 125 whole to the power 3x plus 2 is equal to 3125 whole to the power 3x minus 12, and find the value of x. Okay. So 125 can be written as 5 cube and whole to the power 3x plus 2. 3125 can be written as 5 to the power 5 and whole to the power 3x minus 12. So now we have power whole to the power 3x plus 2. So powers will get multiplied. So 3 gets multiplied with this 3x plus 2. So 3 into 3x plus 2 will become 9x plus 6. 3 will be multiplied with this entire power. Okay. So we'll get 9x plus 6, and here we'll get 5 will be multiplied with this entire power. So we'll get 15x minus 60. So we'll get 5 to the power, this will imply that 5 to the power 9x plus 6, and that will be equal to 5 to the power 15x minus 60. Okay. Now bases are same on both sides of the equation, so powers also must be equal. So this must be equal to this. Okay. So in the next step we can write 9x plus 6 is equal to 15x minus 60. So now we have a linear equation where variable is x. We can solve this and get the value of x. So we'll have 6x equal to 66. So x will be equal to 11. So x equal to 11 is the answer. Fine. So in this case we had to find the value of the variable x. Alright. Let us look at next question. Question number 6 on your sheet. In this we have solve for x. We have 9 to the power 5x minus 7, and on the right hand side it is 9 to the power 3 to the power 1 to the power 3 to the power 4 to the power 5. Okay. So on the right hand side we have 9 to the power 3 to the power 1 to the power 3 to the power 4 to the power 5. So now what we see here is, look at this one. This is nothing but 1 to the power 3 to the power 4 to the power 5. So in this circled expression, we have 1 to the power 3 to the power 4 to the power 5. So the base is actually 1. Now 1 raised to any power will always give you 1, isn't it? So can I say this circled value is going to be 1 only, right? Because this power 3, 4 and 5, those do not matter because they are power on 1. 1 to any power is always equal to 1. So the circled value is equal to 1. Okay. So what do we have? Can I say this is same as saying 9 to the power 5x minus 7 is equal to 9 to the power 3 to the power 1, right? This circled value is nothing but 1. So now bases are same on both sides, 9. So powers must be equal. So we can say 5x minus 7 must be equal to 3 to the power 1. 3 to the power 1 is nothing but 3. So we can write 5x is equal to 3. This minus 7 will go on the right hand side. 3 plus 7 is 10. So what is x? X is equal to 2. Okay. I hope it is clear. Pretty simple. So there were a lot of powers. So we do not have to be worried about too many powers, because the one, once you have 1 in the middle, now 1 raised to any power will always give you 1 only. Fine. I hope this is clear. This is question number 4 on your sheet. It is saying what are the values of x and y that satisfy 2 to the power x into 9 to the power y is equal to 648, and 4 to the power x into 27 to the power y is equal to 46656. So how to solve this? So let us first look at this expression. So 2 to the power x into 9 to the power y is equal to 648. Okay. So 648, if we factorize this, it can be written as 8 into 81. Okay. And 8 is nothing but 2 to the power 3 and 81 is nothing but 9 square. So if you compare this with this on the right hand side, so can we say x will be equal to 2 and y will be equal to 9? If you observe these two, 2 to the power x into 9 to the power y is equal to 2 to the power 3 into 9 to the power 2. So x must be equal to 3 and y must be equal to 2. Okay. Similarly, if I look at the second one, it is 4 to the power x into 27 to the power y is equal to this 46656. We'll do the same process, factorize the right hand side. So after factorization, you can write it as 4 to the power 3 into 27 square. Now compare these two again. If you compare these two, again we get x is equal to 3 and y is equal to 2. Okay, x is equal to 3 and y is equal to 2. So looking at this 1 and 2, you can say x is equal to 3 and y is equal to 2. Fine. Okay. Now see, this could have been done till here only, and we could have said the answer is going to be x is equal to 3 and y is equal to 2. Fine. Because this question does not have an option, and if the option was cannot be determined, then we will have to check the second expression also. But since this question does not have any option, we just have to solve and check. So after solving this much only, we could have said that x is equal to 3 and y is equal to 2. And just to cross check, you could have done x equal to 3 and y equal to 2, put the values here, and you could have cross checked whether it is correct or not. Okay, that could have been done. Alright, fine. Let us look at next question. This is question number 1 in additional question. Now here it says 7 to the power 3x plus 2 plus 7 to the power 3x minus 2 is equal to 16,814, and we have to find the value of x. Okay, fine. So in this one, can we write this as 7 to the power 3x into 7 to the power 2? I'm using the product rule the other way around. Okay, so the power is 3x plus 2. When you break the powers, you can write it as 7 to the power 3x into 7 to the power 2. Here similarly you can write 7 to the power 3x into 7 to the power minus 2. Okay, the second expression can be written like this. So in these two, you can write 7 to the power 3x into 7 square, and here you can write 7 to the power 3x into 7 to the power minus 2, and on the right hand side we have 16,814. In these two terms you can take 7 to the power 3x as common. So when you take that, you will be left with 7 square, which is 49, and here you will be left with 7 to the power minus 2, which can be written as 1 by 7 to the power 2. So that can be done as 1 by 49. Okay, right hand side is 16,814. So you can solve these two. 49 into 49 is 2401, plus 1 gives you 2408 divided by 49, that is equal to 16814. So from this you will get the value of 7 to the power 3x. So keep it in the left side, 7 to the power 3x, and take 2402 into 49 on the right hand side. So this will become 16814 into 49 divided by 2402. If we solve and simplify this, 2402 into 7 is 16814. Okay, 2402 into 7 is 16814. So 7 into 49, 7 into 49, which is nothing but 7 cube. 7 into 49 is nothing but 7 cube. So 7 to the power 3x is equal to 7 to the power 3. The bases are same, so powers must be equal. So 3x must be equal to 3, so x must be equal to 1. Okay, I hope this was clear. Fine, let us move on to the next example. Okay, so we have question number 12 in your sheet. It says x is equal to 7 plus 7 to the power 1 by 3 plus 7 to the power 2 by 3. Then find the value of x cube minus 21x square plus 126x. Now see, x is this big value 7 plus 7 to the power 1 by 3 plus 7 to the power 2 by 3. If I put this value of x here as it is and then I calculate, then it will take a long time. So this is going to take a very long time to solve. So what we do is we look at an alternative approach. So the correct way of solving this question will be like this. So in this expression you take this 7 on the left hand side. So we can write x minus 7 is equal to 7 to the power 1 by 3 plus 7 to the power 2 by 3. Okay, what you do is take whole cube on both sides. So cubing both sides. So a minus, this will be of the form x minus 7 whole cube, which is a minus b whole cube, and on the right hand side we have 7 to the power 1 by 3 plus 7 to the power 2 by 3 whole to the power 3. So on the right hand side we have expression of the form a plus b whole cube. So we'll use the formula for a minus b whole cube and a plus b whole cube, and this is what we get. So on the left hand side I'll get x cube minus 21x square plus 147x minus 343, and on the right hand side we'll get 7 to the power 1 by 3 whole to the power 3. That will give me 7. 7 to the power 2 by 3 whole to the power 1 by 3. That will give you 7 square, and the other two terms will be 3ab. Okay, so when we do that, what do we get further? On the right hand side you get 7 plus 49, this is 49, this is 3 into 7, this is 3 into 7, which is 21, and 7 to the power 1 by 3 plus 7 to the power 2 by 3. Look at these two. this is nothing but x minus 7. Okay, so this value inside bracket is nothing but x minus 7. So in place of this I can write x minus 7, and then you simplify further. Take these terms on the left hand side. So x cube minus 21x square plus 147x. This 21x will go on the left hand side. Take 343 on the right hand side. Fine. So when you simplify this, this will give you x cube minus 21x square plus 126x. These two will give you 126x, and on the right hand side if you solve all this you will get 252. So this is what the question was asking you, right? So this is what we have here. The value will be 252. Okay, so what is the answer for the question? The answer for the question is 252. Fine. Okay, so in the next part of indices and surds, we'll take up some questions on comparison of expressions or numbers having powers, and then we will look at what are surds and finding square root of surds, comparison of surds, and rationalization of surds. Fine. Thank you. Hello students, welcome to Time Classes. This session is part 2 of indices and surds. In this session we'll first look at questions on comparisons, where we will compare numbers which involve some power of the numbers. Then we will look at what are surds and understand the process of rationalization of surds. We'll also look at how to find square root of surds and how to compare two or more surds. Okay, so I hope you have the required handout, which is QAHO 1002125. So let us begin with the session. So let us look at question number 7 in your sheet. Now question number 7 has different parts, so we'll start with the first part. And what do we have to do in these questions? Question says, in each case compare the numbers and identify the greater one. Okay, so the first part is 32 to the power 175 and 16 to the power 200. So if you observe carefully, 32 and 16, these numbers are powers of 2. So we know 2 to the power 5 is 32 and 2 to the power 4 is 16. So in this case it will be possible to equate the bases and then we will compare the powers. Okay, so let's see how to do that. So 32 to the power 175, right? Can I write 32 as 2 to the power 5? Isn't it? 32 is nothing but 2 to the power 5. So 2 to the power 5 and whole to the power 175. Fine. So finally it will become 2 to the power 5 into 175. So these two powers will get multiplied. So 5 into 175 will get multiplied and we'll get 2 to the power 875. 5 into 175 is 875. So 32 to the power 175 will finally become 2 to the power 875. Isn't it? Alright. Now, what is the next one? Next number is 16 to the power 200. 16 is also some power of 2, isn't it? What is 16? 16 is 2 to the power 4. So 16 is written as 2 to the power 4, that raised to whole power 200. Okay, so that will become 2 to the power 4 into 200. Power to the whole power means power will get multiplied. So 4 into 200, it is how much? It is 800, right? So 4 into 200 is 800. So finally it becomes 2 to the power 800. So 32 to the power 175 is equal to 2 to the power 875, and 16 to the power 200 is equal to 2 to the power 800. Now both the numbers have now the same base. The base is 2, right? Both the numbers have the same base. Here also we have 2 and here also we have 2. Now we just have to compare the powers. So 2 to the power 875, 2 to the power 875 is definitely bigger than 2 to the power 800. Okay. So we can say the original number 32 to the power 175 is bigger than 16 to the power 200. Okay. So 32 to the power 175 is bigger than 16 to the power 200. Now if you have noticed carefully, in this case it was possible to equate the bases of the two numbers. So we have used a common base which is 2. In questions where it is not possible to equate the bases, we can try and equate the powers. Okay. So let us look at next example. So we have 2 to the power 300 and 9 to the power 225. Okay. So 2 to the power 300, let it be 2 to the power 300 only. But 9 to the power 225, can I write 9 as 3 square? Can I write 9 as 3 square? So 9 can be written as 3 square, and 3 square whole to the power 225. So this 2 and 225 will get multiplied and you will get 450. So that becomes 3 to the power 450, right? 2 to the power 300 and 3 to the power 450, definitely 3 to the power 450 will be bigger, because the base 3 is bigger than 2 and the power 450, that is also bigger than 300. So we have two numbers greater than 1. 3 to the power 450 will definitely be greater than 2 to the power 300, right? Fine. Let us look at next example. So in this case 3 to the power 450 is greater than 2 to the power 300. In the third example we have 20 to the power 30 and 8 to the power 40. Okay. Now what we'll do in this case is we'll equate the powers. Okay. So 20 to the power 30, can we take 3 inside and keep 10 outside? So can I write 30 as 3 into 10? So we can write this thing as 20 to the power 3 whole to the power 10, right? 20 to the power 3 is nothing but 8000. So it is 8000 to the power 10. What about 8 to the power 40? Can we write 40 as 4 into 10? So we can take 4 inside and keep 10 outside. So we can write it as 8 to the power 4 whole to the power 10. Fine. What is 8 to the power 4? 8 to the power 4 is nothing but 4096. Okay. It is 4096. Now even if you don't remember what is 8 to the power 4, you can definitely look at it this way. 8 to the power 4 is 8 square into 8 square. 8 square is 64 and 8 square is 64. 64 into 64, the exact value is 4096. But even if you don't know the exact value, you can simply think an approximate value that 60 into 60, that is going to be 3600, right? 60 into 60 is 3600. So 64 into 64 will be somewhat more than 3600, right? But it will not be reaching 8000. 64 into 64 will be somewhat more than 3600, but it won't reach up to 8000. The first number you can clearly see is 8000 whole to the power 10. So 64 into 64, even if you do a rough calculation, you will understand that it will be near about 4000. Okay, so this number is 4096 whole to the power 10. This is 8000 whole to the power 10. So definitely 8000 whole to the power 10 will be bigger than 4096 to the power 10, right? So the original number 20 to the power 30 is greater than 8 to the power 40. Fine. Alright. Let us look at this example. So here we have let us erase a few part. Alright, 7 to the power 1 by 5 and 6 to the power 1 by 4. Okay. Now here you see the powers are in fractions, right? How to compare numbers where powers are in fraction? So what we do is, we'll use a common power on both the numbers. Okay. So that power is 20. Alright. So how did I get 20? Look at the powers 1 by 5 and 1 by 4. So what is the LCM of 5 and 4? LCM of 5 and 4 is 20. So what we are trying to do is, we are trying to use a common power such that this power that we are using in the circle, that gets cancelled by 5 also and that gets cancelled by 4 also. Because 7 to the power 1 by 5, I don't know what is the value, isn't it? Similarly, 6 to the power 1 by 4, I don't know what is the value. So 7 to the power 1 by 5 is same as finding 5th root of 7, and 6 to the power 1 by 4 is finding 4th root of 6. So it is not possible for us to find the value of 5th root of 7 or 4th root of 6. Okay, because it will take a lot of time. So what we'll do is, if we had some natural number power, suppose 7 to the power 5, we can still calculate the value. Suppose 6 to the power 4, we can still calculate the value. Fine. So we are trying to have a power which is a natural number, so that comparison will be easier to do. Fine. For that, what we are doing is, we are using a power, a common power to both these numbers, such that this power gets cancelled by 5 also and gets cancelled by 4 also. So the smallest number that can be cancelled by 5 and 4 is nothing but LCM of 5 and 4. So use 20 as a common power to both the numbers. So 7 to the power 1 by 5 whole to the power 20 and 6 to the power 1 by 4 whole to the power 20. So power to the whole power means powers will get multiplied. So here we'll have 1 by 5 into 20, which is 4, and here we'll have 1 by 4 into 20, which is 5. So we are left with, this will become 7 to the power 4 and this will become 6 to the power 5. Okay. 7 to the power 4 we can calculate, 6 to the power 5 also we can calculate, and then we can compare which is bigger and which is smaller. So what is 7 to the power 4? It is 2401, and what is 6 to the power 5? It will be 7776. Okay. So the right hand side number is bigger. So 6 to the power 1 by 4, the original number was 6 to the power 1 by 4. So 6 to the power 1 by 4 will be greater than 7 to the power 1 by 5. Fine. Okay. Now, see, this calculation you don't have to do it precisely. 7 to the power 4 is 2401. Even if you don't remember, you can simply think of it as 7 square and 7 square. It is 49 into 49. So which is approximately 50 into 50, a little less than that. 50 into 50 is very easy to calculate, 2500. So 49 into 49 will be a little less than 2500. Fine. 6 to the power 5 can be thought as 6 cube into 6 square. Okay. 6 cube is 216 and 6 square is 36. So even if I do approximate calculation, let's take it as 200 and let's take 36 as 30. So this is going to be 6000. So 200 into 30 is 6000. So 216 into 36 is definitely greater than 6000. So this number is less than 2500 and this number is greater than 6000. So even a rough calculation will tell you that this side is going to be bigger than this side. Okay, 6 to the power 5 is going to be bigger than 7 to the power 4. So finally we can say 6 to the power 1 by 4 is greater than 7 to the power 1 by 5. Okay, fine. Let us move on. So let's arrange these numbers. So we have 11 to the power 1 by 5, 25 to the power 1 by 6. Here we have 25 to the power 1 by 6 and 7 to the power 1 by 4. We have to arrange them in ascending order. Fine. So let us consider these two numbers first. So again you see power sign in fraction. We'll use a similar approach that we just used in the previous question. So for 6 and 4 LCM is 12. So let's use a common power 12 on both the numbers. So 25 to the power 1 by 6 whole to the power 12 and 7 to the power 1 by 4 whole to the power 12. So we'll get 25 square and 7 cube. So 1 by 6 into 12 is 2 and 1 by 4 into 12 is 3. 25 square we know is 625 and 7 cube is 343. So 625 is definitely greater than 343. Fine. So that means 25 to the power 1 by 6 is greater than 7 to the power 1 by 4. Let's call it 1, relation 1. Now let us compare these two numbers, 11 to the power 1 by 5 and 7 to the power 1 by 4. Let's compare these two. Again we'll use a similar approach. So 1 by 5 and 1 by 4, LCM of 5 and 4 is 20. So let's use a common power 20 on both the numbers. So finally we get 11 to the power 4 and 7 to the power 5. 11 to the power 4 is 14641 and 7 to the power 5 will be 16,807. Fine. So as we can see, 7 to the power 5 is greater than 11 to the power 4. Here also you can do a rough estimation of the value even if you don't calculate it properly. Fine. So in this case 11 to the power 1 by 5 is less than 7 to the power 1 by 4. Fine. Okay. So from 1 and 2, what do we observe? What will be the final numbers in ascending order? So as we can see, 11 to the power 1 by 5 is less than 7 to the power 4 and 7 to the power 1 by 4 is less than 25 to the power 1 by 6. So 11 to the power 1 by 5 is less than this and 7 to the power 1 by 4 is less than 25 to the power 1 by 6. So this is the correct ascending order. Okay. I hope this is clear. What are surds and what is the process of rationalization? Okay. So what are surds? First of all, surds are irrational numbers which are written in roots or radical form. Okay. Whenever we write a number in this form, a root sign is involved. This sign is known as radical sign. So this is known as a radical form. So any irrational number which is written in the form of roots or radical form, such a number is known as a surd. Okay. So for example, root of 2, root of 5, cube root of 17. These are all surds. So we can have cube root also. This is also a surd. 2 plus root 3. This entire number is a surd. Specifically we call it as a binomial surd because it has two terms. Okay. It is known as a binomial surd. So we can have a trinomial surd also, which will have three terms. Okay. Now next thing, let us understand what is the conjugate or rationalizing factor of a surd. Fine. So conjugate is also known as rationalizing factor of a surd. So let's look at surds here. So if the surd is of the form a plus root b, then its conjugate or rationalizing factor will be a minus root b. So what you have done is just change the sign of the irrational part. So here root b is the irrational part and the sign is plus here, so what you do is just change the sign in front of the irrational part. So this plus becomes minus here. Okay. So a minus root b is the conjugate or rationalizing factor of a plus root b, and a plus root b will be the conjugate or rationalizing factor of a minus root b. So basically these two are conjugates of each other or rationalizing factors of each other. Fine. Now, what is the meaning of conjugate or rationalizing factor? What it basically means is, if you multiply these two quantities, a plus root b and a minus root b, so a plus root b into a minus root b, if you calculate that, you will get a square minus b. The root will disappear. So a square minus b will be a rational number. So that is why we are calling it as a rationalizing factor, because when you multiply the rationalizing factor with a surd, it will result in a rational number. That is why it is known as a rationalizing factor. So what we do for finding the conjugate of a surd, you just change the sign of the irrational part. If the surd is of this form, where one part is rational and the other part is irrational. Okay. Now you can also say that the rationalizing factor of a plus root b is plus or minus a minus root b. So basically this has two things, a minus root b, or we can have minus a plus root b. So this is also a rationalizing factor, and this can also be a rationalizing factor. Fine. For this, both of these can be rationalizing factors, because by multiplying both of them, we are going to get a rational number. But what we usually do while doing rationalizing factor is this, that you just change the sign of the irrational part. Okay. Just change the sign of the irrational part. Now what if both the parts are irrational? So root a plus root b, here both the parts are irrational. So in that case what you do is just change the sign between the two terms. Okay. So plus will become minus and minus will become plus. So here also we can say these two are conjugates of each other. So if both the parts are irrational, you just change the sign which is in between the two terms. So root a plus root b, its conjugate will be root a minus root b, and root a minus root b, its conjugate will be root a plus root b. Fine. Okay, what do we do with the conjugates? So let us look at question number 13 on your sheet. So what is the use of this conjugate or rationalizing factor? Now look at this. Look at this. Can we do the normal addition that we do while adding fractions? What do you do when you add fractions? You take the LCM of the denominators. But you see, LCM of these two denominators, which are both surds. So if I do it normal addition by taking LCM of these two numbers, then it will become very complex or very difficult, right? Because we have two surds. So taking the LCM of these two surds will mean just multiplying these two surds and then finally getting the simplification and then solving. But that will take more time. So it becomes very difficult to add such fractions where denominator is a surd. So what is the easy way out? We rationalize each of the surds so that the denominator will become a rational number, and once the denominator becomes a rational number, it will become easy to take LCM and then simplify. Fine. So what we do is, first step, rationalize both the terms, this also and this also. So rationalizing means rationalizing the denominator of both the terms. So 11 plus root 120, what is the conjugate of 11 plus root 120? It will be 11 minus root 120. So what I do is multiply the conjugate of this denominator in the numerator as well as denominator. So I have to multiply in the numerator as well as denominator both. Why? Because I can't change the fraction. So whatever I have to multiply in numerator, I should multiply the same thing in denominator. Okay, or vice versa. So to make this denominator as a rational number, I multiply its conjugate with it, or rationalizing factor with it. So the rationalizing factor of this will be 11 minus root 120. So multiply 11 minus root 120 to the numerator as well as denominator, both the terms. Similarly, what is the conjugate of 13 minus root 168? So change the sign of the irrational part. So it will be 13 plus root 168. So again multiply the conjugate of 13 minus root 168, which is 13 plus root 168, in the numerator as well as denominator, both. Now once we do that, let us see what happens. So this thing, now we have 11 plus root 120 into 11 minus root 120. This is same as saying a plus b into a minus b, which is a square minus b square. So 11 square is 121 and minus root 120 square. Root 120 square will be nothing but 120. So 11 square is 121 minus 120, that is 1. Fine. So here in the first term the denominator will become 1. So in the numerator you will be left with only 11 minus root 120. In the second, 13 minus root 168 into 13 plus root 168. So again a square minus b square. 13 square is 169 and root 168 square is 168. So 169 minus 168 is again 1. So denominator is 1 and the numerator will be 13 plus root 168. So in both the terms the denominator becomes 1, and since the denominator becomes 1, it means you can simply add the numerator. So here we will have 11 minus root 120, here we will have 13 plus root 168. So finally you will be left with 11 minus root 120 plus 13 plus root 168. So this 11 plus 13 added together will give you 24. So we will have 24 minus root 120 plus 168. Okay, fine. So question number 14 on your sheet. Here we have 3 terms and the denominator of each of these 3 terms is a surd, where both the terms are irrational. So how do we do this? Again rationalize the denominator of each of the terms and then we will simplify. So root 11 plus root 10, the conjugate is root 11 minus root 10. So multiply root 11 minus root 10 in the numerator as well as denominator. So in the numerator also we'll have root 12 into root 11 minus root 10, and the denominator will be root 11 plus root 10 into root 11 minus root 10. Similarly here the conjugate will be root 12 plus root 10. So multiply root 12 plus root 10 in both numerator as well as denominator. In the third term the conjugate of root 12 minus root 11 will be root 12 plus root 11. So in that case again multiply root 11 plus root 11, root 12, multiply root 12 plus root 11 in both numerator as well as denominator. So here you have a plus b into a minus b, so that is a square minus b square. So root 11 square is 11 and root 10 square is 10. So 11 minus 10 is 1. Okay. So here we will be left with only this thing divided by 1. So that can be written as root 12 into root 11 minus root 10. Here you will have a minus b into a plus b, that is a square minus b square. So root 12 square minus root 10 square will give you 12 minus 10, which is 2. So in the denominator here you are going to get 2, and from that 2 you can cancel the numerator 30. So you will get 15 here. So in the denominator now you have 1 because you cancelled 30 by 2, which is 15, and numerator becomes 15 root 11 into inside bracket root 12 plus root 10. Okay. Third term, a minus b into a plus b. So a square minus b square. So here again you will have a square minus b square. So root 12 square is 12, root 11 square is 11. So 12 minus 11 is nothing but 1. So you will be left with the numerator, this one. Okay. So we have got all the three terms. Now we have to further simplify this. So it is root of 132, 12 into 11 is 132, and root of 120, 12 into 10 is 120. Here 15 into root 11, root 12 is again root 132, and minus 15 root 11 plus root 10 is minus 15 into root 110. Here 15 into root 12 is 15 root 12, and 15 into root 11 is 15 root 11. Okay. Now we can write 15 root 12 here plus 15 root 11, which is this term, minus 14 root 132. This comes from these two. So we have minus 15 root 132 and plus root 132. So minus 15 and plus 1 will give you minus 14. So minus 14 root 132, which is this. Minus 15 root 110, which is this, and minus root 120, which is this. Fine. Okay, let us look at question number 15 in your sheet. So it gives you a is equal to 7 plus root 48 and ab. Here ab means a into b. Okay. So a into b is 1. What is the value of a square minus ab plus b square? So since a into b is equal to 1, can I say b will be equal to 1 by a, right? So b is equal to 1 by a. So we can write b is equal to 1 by 7 plus root 48, because a is 7 plus root 48. So 1 by a will be 1 by 7 plus root 48. Now if you rationalize this to simplify, so rationalize the denominator of this expression, so you will finally get 7 minus root 48. So just multiply 7 minus root 48 in the numerator as well as denominator. The denominator will become 1 and the numerator will become 7 minus root 48. So b is 7 minus root 48 and a is 7 plus root 48. Now what are they asking for? They are asking for what is the value of a square minus ab plus b square. That can be written as a square minus 2ab plus b square plus ab. So this minus ab can be written as minus 2ab plus ab. So this ab has been written in the end, so that you can see that a square minus 2ab plus b square is nothing but a minus b whole square. So a minus b whole square plus ab. Now what is a minus b? A is 7 plus root 48, b is 7 minus root 48. So a minus b will be 7 plus root 48 minus of inside brackets 7 minus root 48. So 7 and minus 7 will cancel out, and root 48 minus of minus root 48 will become root 48 plus root 48, which is 2 root 48. Okay. So a minus b will be 2 root 48, 2 root 48 square plus ab is equal to 1. It is already given in the question. A into b is nothing but 1. So in place of ab we can write 1. So 2 root 48 square will become 192 and plus 1. 192 plus 1 is 193. Okay. So this is the answer. I hope it is clear. Alright. Now remember, when you are rationalizing a trinomial surd, means a surd having 3 terms, in that case while taking the conjugate you have to remember that out of the 3 terms you take 2 terms together and the third term as separate, and then find its conjugate. So in that case you will have to rationalize twice. Okay, in that case you will have to rationalize twice. Fine. Okay, now we'll look at how to compare surds. Okay, so let's look at additional question number 5. What do we do to compare two surds? So we have taken an example and we'll understand what to do. So here we have three surds, root 15 plus root 26. The other one is root 21 plus root 22. The third one is root 13 plus root 29. So now if I go on calculating the value of root 15, what I know about root 15 is it will lie between, root 15 will lie between which two numbers? So 3 square is 9 and 4 square is 16. So we can say root 15 will lie between 3 and 4. But what is the exact value we do not know. So we don't have to calculate the value of root 15 manually. Now if calculator is allowed, you can think that simply using the calculator will get you the answer. Okay, but remember, in all the exams calculator is not allowed. In only CAT calculator is allowed. In other exams calculator is not allowed. So you should know how to do it without the help of calculator. Now what happens in these problems is that you can't actually calculate the value manually and then compare, because that is going to take long time. So what is the process? The process is this: you find the whole square of all the surds and then compare. Okay, you find the whole square of all the surds and then compare. If one squaring is not sufficient, then you square once again. So ideally the process is this: you keep squaring again and again till you can conclusively see that which number is bigger and which number is smaller. So the process is squaring all the surds and then comparing. If one squaring is not enough, we'll need to square again. So let us look at these three numbers. So what is the whole square of root 15 plus root 26? It will be a plus b whole square, that is a plus b whole square. So a plus b whole square is a square plus b square plus 2ab. So this will be 15 plus 26 plus 2 root 15 into 26. So 15 into 26 is 390. 15 plus 26 is 41. So this is 41 plus 2 root 390. Okay. Similarly, the second one, root 21 plus root 22. Squaring will give you 21 a square plus b square plus 2ab. So 21 plus 22 plus 2 root 462. 21 into 22 is 462. So 21 plus 22 is 43. So 43 plus 2 root 462. And the third one is root 13 plus root 29. Squaring it will give you 13 plus 29 plus 2 root 377. So that will give you 42 plus 2 root 377. Now in these three you can clearly see that the rational part 43 is the biggest and the irrational part 2 root 462 is also the biggest among the all three. So in this particular value, the rational part is bigger than the rational part in the other two, and the irrational part is also bigger than the irrational part in the other two. So the sum of these two numbers will definitely be more than the sum of these two numbers and these two numbers. So which is the biggest out of these three? That was the question. Which is the greatest or the biggest? So root 21, this number is the biggest. So for comparing surds, we'll find the square of all the surds involved and then we will see which is bigger. If one squaring is not enough, we'll need to square again. Fine. Okay, let's look at another example. So here we have to compare these two surds, root 7 plus root 31 and root 14 plus root 23. Okay. So let us say a is root 7 plus root 31 and b is root 14 plus root 23. So we'll find a square, b square and then compare. So what will be a square? Whole square of this. So a plus b whole square will become a square plus b square plus 2ab. So this is 38 plus 2 root 270. This is b, root 14 plus root 23. So b square, root 14 plus root 23 whole square. So 14 plus 23 plus 2 root 14 into 23, a square plus b square plus 2ab. So that will give you 37 plus 2 root 322. So now you see the rational part here is 38 here, and here it is 37. So can we write it as 37 plus 1 plus 2 root 217. Okay. So I have just separated 37 so that here 37 and here 37, these are equal. So we basically have to compare this quantity and this quantity to finally understand which one is bigger. Okay, let us see. So consider root of 217, which is this quantity. So what we know is root of 217 will lie between 14 and 15, because 14 square is 196 and 15 square is 225. So root of 217 will lie between 14 and 15. So we can say 2 root 217 will lie between 14 into 2 and 15 into 2. So 14 into 2 is 28 and 15 into 2 is 30. And we are adding 1 to it. So 28 plus 1 is 29 and 30 plus 1 is 31. So 2 root 217 plus 1 will lie between 29 and 31. Fine. Okay. What about root 322? Root 322 will lie between 17 and 18, because 17 square is 289 and 18 square is 324. So 2 root 322 will lie between 17 into 2 and 18 into 2. So which means it will lie between 34 and 36. Okay. So this quantity will lie between 34 and 36, and this quantity will lie between 29 and 31, and the initial quantity 37 is equal in both the cases. So we can clearly compare that the second quantity b will be greater. Okay, from 1 and 2 you will see that this quantity is less than this quantity, right? So as we can clearly see, 29, something which lies between 29 to 31 will definitely be less than something which lies between 34 and 36. So we can say 38 plus 2 root 217 will be less than 37 plus 2 root 322. Okay. So which is the greater in these two? The second one is greater. So b is greater, which means this quantity is greater. Okay. So that is the answer. Root 14 plus root 23 is greater. Okay. Now let us look at how to find square root of a surd. Fine. Okay. Now this is how we'll find the square root of a surd. If the surd is of this form, a plus root b, its square root will be of the form root x plus root y, wherein we have to basically find the value of x and y. Okay. So if there is a surd which is of the form a plus root b, its square root will be in the form root x plus root y. And if there is a surd of the form a minus root b, its square root will be of the form root x minus root y. So if there is a plus in between, in the square root also will have a plus in between. If there is a minus in between, in the square root also will have a minus in between. Okay. So basically we have to find the value of x and y, and let's understand the process. So this is the form of the square root. So a plus root b, its square root will be of the form root x plus root y, and a minus root b, its square root will be of the form root x minus root y. Let us understand this with an example. So let's try question number 16 in your sheet. So it says find the square root of 30 plus 20 root 2. So let us say square root of 30 plus 20 root 2 is root x plus root y. So here we had plus in the middle, so here also we'll have plus in the middle. So let us say it is equal to root x plus root y. Now the next step is squaring both sides. So when you square both sides, on the left side we have 30 plus 20 root 2. On the right hand side it is root x plus root y whole square. Okay. So it is a square plus b square plus 2ab. So root x square is x, root y square is y, and 2 root x into y. Fine. So now what will happen next is, whenever you are equating two surds, the right hand side is also a surd and the left hand side is also a surd. Whenever we equate two surds, then the rational part will be equal to rational part and the irrational part will be equal to irrational part. So here the rational part is x plus y, it will be equal to 30, and the irrational part is 20 root 2, it will be equal to 2 root xy along with the sign. So equating the rational part and irrational part on both sides, we'll have x plus y is equal to 30 and 2 into root xy will be equal to 20 root 2. Now 2 root xy is equal to 20 root 2, we can write 20 as 2 into 10 into root 2. 20 root 2 can be written as 2 into 10 into root 2. So this 2 you can leave outside, and if you take this 10 inside the square root, so outside it is 10, when you take it inside the square root it will become 100, right? Because square root of 100 is 10. And 2 was already there, this 2 was already there, so 2 into 100 is 200. So ultimately it becomes 2 root 200. So now compare these two. 2 root xy is equal to 2 root 200. So if you equate these two, it means x into y, this x into y must be equal to 200. Okay, so x into y is equal to 200. So now look at equation 1 and equation 2. We need two numbers x and y, where x plus y is 30 and x into y is 200. So what are those two numbers? A little bit of hit and trial. You can say one of the numbers is 20 and the other number is 10. So from 1 and 2 we can say x is 20 and y is 10. So what is my square root? My square root was root x plus root y. So our square root will be root 20 plus root 10. Root 20 can be further simplified and written as 2 root 5, because 20 is 4 into 5. So square root of 20 will be square root of 4 into 5. Square root of 4 is 2. 2 comes outside, you will be left with root 5. Okay, and root 10 is root 10. So finally this is my square root. Okay, if you have noticed carefully here, let's look at here. Okay, so if we have 30 plus 20 root 2, okay, so if we had written it as 30 plus, instead of 20 root 2, here we had 20 root 2, isn't it? 20 root 2, finally we wrote it as 2 root 200. Okay, so this is my original surd, which can be written as this. Okay, so 30 plus 2 root 200. So what we are trying to do is, we are ensuring that there is a 2 outside the square root. If we ensure that, then it becomes very easy, because now we have to only do one thing: find two numbers x and y such that x plus y, find two numbers x plus y such that x plus y is equal to 30 and x into y is 200, right? So those two numbers are 20 and 10. Then it will become very easy. We can be sure of applying a shortcut without getting into the entire process. But the condition is there must be this 2 outside the square root. Then my job becomes very easy. Just find two numbers having sum as 30 and the product as 200. Those two numbers are 20 and 10. So my square root is root 20 plus root 10. Okay. Let's try another example. So let's find the square root of 20 minus 6 root 11. So here we will try to have 2 outside the square root. So 6 can be written as 2 into 3. Take this 3 inside. So 3 goes inside, it becomes 9, and 9 into 11 is 99. So 20 minus 6 root 11 can be written as 20 minus 2 root 99. So we have ensured that there is a 2 outside the square root sign. Okay. Once you do that, now my only job is to find two numbers x and y such that x plus y is 20 and x into y is 99. Okay. Now we only have to think about two numbers whose sum is 20 and the product is 99. What are those two numbers? Those two numbers will be 11 and 9. A little bit of hit and trial. Okay. Two numbers having sum as 20 and product as 99 will be 11 and 9. So what will be my square root? My square root will be root x minus root y. Remember, it is of the form a minus root b form. So in this case, my square root will be of the form root x minus root y. Now in this case, you have to keep in mind that x should be greater than y, because if x is less than y, then root of x minus root of y will become negative. And what are we doing? We are finding square root of this number. Surd is also a number. Okay. So when we find square root of a number, by default it is positive square root. So in this case, you have to keep in mind that while writing root x minus root y in the answer, we have to ensure that x is greater than y. Okay. This will ensure that we get a positive square root. Okay. So 11 is greater than root 9 is smaller. So square root will be, we only have to find two numbers, we have already discussed. So we have to find two numbers where x plus y is 20 and x into y is 99. So those two numbers are 11 and 9. So let's take x as 11, y is 9. So our square root will be root 11 minus root 9. And root 9 is nothing but 3. So we can write it as root 11 minus 3. Okay. Now remember, if you write root 9 minus root 11, that will not be correct, because root 9 minus root 11 will give you a negative value. Okay. Because root 9 is less than root 11. So here we have to ensure that you have to do bigger number minus smaller number to get a positive square root. Okay. I hope this point is clear. Alright. Okay, let's look at this example. Find the square root of root 1280 minus root 1260. So 1280 can be written as 5 into 256, 1260 can be written as 5 into 252. So you can take root 5 as common and you are left with root 256 minus root 252. Root 256 is nothing but 16. So now root of 5 and square root of 5 can be written as 5 to the power 1 by 4. And then this is nothing but 16. 16 minus 252 can be written as 4 into 63. So here you can take 2 outside, because square root of 4 will be 2. So finally we get 5 to the power 1 by 4 into root of 16 minus 2 root 63. Now for this part, we only have to, since we already have 2 outside the square root of 63, so we only have to find two numbers x and y such that x plus y is 16 and x into y is 63. Okay, isn't it? So we can use that trick. So two numbers where the sum is 16 and the product is 63. Let's find that. A little bit of hit and trial will give you those two numbers as 7 and 9. Okay. So root of 16 minus 2 root 63 will be root 9 minus root 7. 9 is the bigger number, so we'll write root 9 first and then minus root 7. Root 9 can be written as 3. So we can write 3 minus root 7. So finally the square root will be 5 to the power 1 by 4 into 3 minus root 7. Okay, I hope this is clear. Okay, let us look at one more additional question, question number 4. Here we have to find the square root of 6 minus root 11. Now this is very simple, but there is no 2 outside root 11. Okay, there is no 2 outside root 11, and inside the square root in 11 it's a prime number, there is no factor of 4, so you can't take root of 4 as 2 outside. Fine, so we'll have to do something else here. So what we'll do is to bring 2 here, what we do is we multiply this entire thing by 2 and also divide by 2. Fine, so we cannot simply multiply 2 to keep the balance, we have to divide also by 2. So 6 minus root 11, you multiply and divide this by 2. Okay, so 2 into 6 minus root 11 divided by 2, that will become 12 minus 2 root 11 by 2. Now we have to find the square root of this. So square root of this can be written as, in the denominator we have 2, so square root of 2 is root 2. So this 2 can be taken outside and written as 1 by root 2, and we are left with square root of 12 minus 2 root 11. Now we have ensured that there is a 2 outside. So now we need only 2 numbers where the sum is 12 and the product is 11. Those 2 numbers are 11 and 1. Sum is 12 and the product is 11. Those 2 numbers are 12 and 1, right? So 1 by root 2 will remain outside, and the square root of this quantity will be root 11 minus root 1. Root 1 is nothing but equal to 1. So root 11 minus 1. So this is my final square root of 6 minus root 11. Okay, I hope it is clear. Now, so I hope you have learned all the concepts in indices, surds. Raise all the concepts and then try the remaining questions in the sheet. Thank you so much.